Okay, so we are going to discuss these papers. I mean, questions theory parts here. So this is October November 20, paper 42, question number 3. And in this question, actually, the situation is related with some electrical energy and kinetic energy. So kinetic energy of the air passing through the wind turbine is every minute is 720,000 joule, yani 720,000 joules. The electrical output of the turbine is 9 ampere, and the potential difference is 240 volts. Calculate the percentage efficiency of this turbine. So when you are handling these type of questions, because this is annual paper definitely, so we would have some concept of electrical energy also, but here in these lectures or in these lessons we had not talked about the electrical energy. But I will let you know that when these type of questions will be there, you have to note one thing, that electric power formula is different, that is related to voltages and current. So electric power is equals to potential difference, yani V and I, V times I. So you can simply use that P is equals to VI. This is that equation what you have to use here. And because this question is related to efficiency, so efficiency is equals to what? Useful output. Useful output, as I told you, that if you are using power, then use power divided by total input. And here again, if you are going to use power at the top, you will use power at the denominator as well. So what is the useful output power? That is electrical power. So you will use V into I. So 240 times 9 ampere, that is your useful output power. And what is useful input, total input power? This is energy and this is time taken. So it means I will multiply that 720,000 with 1 minute. 1 minute is basically how much seconds? 60 seconds. So if you just multiply this by 100, is there anyone uh, equipped with calculator?
Yes, sir.
Okay, solve it, please.
Okay, sir. I got an unusual answer. Um,
Oh,
I got 0.005.
really?
Yeah.
Yes, anyone else?
Wait, sir, let
It will
me
be small one. Yeah, Zainab, what's your answer?
wait, sir, let me do it.
240 times 9 times 100 directly divided by 720,000 times 60. खदीजा कैलकुलेटर है आपके पास?
216.
अच्छा मेरे पास कैलकुलेटर नहीं पड़ा हुआ so that
Sir,
I could
मैं
calculate it.
0.05 आया है. 0.05.
0.05%.
Yes.
Okay. Yes, where is Khadija? Khadija, please endorse this because both of my students are getting different numbers. That's why calculator only.
No, sir. I also got 0.005.
0.005 or 0.05?
0.05. I mean, yeah.
Sir,
No, no, no.
Khadija,
No,
something.
0.005. Sorry.
Okay. And Mariam, sorry, Zainab, you got 0.005?
No, sir, I got 0.05.
Okay. Calculator there. यार, जल्दी से. चलो. अरे यार, मस्तियाँ नहीं किया कर. Calculator निकालो, जल्दी करो शाबाश. 240 times 9 times 100. And 900 divided by bracket लगाओ 720,000 times 60 ब्रैकेट में लिखो 720,000 720,000 equal to, then again divided by 60. So it is 0.005. Yes. Who won this game?
Mariam.
मरियम. अब हमें पता चला तुम्हारा पेपर अच्छा हुआ. Yes. It is 0.005%, right? Is it clear to all?
Yes,
So
sir.
Yes,
that's why
sir.
this question is of 5 marks. So I believe that it would be quite clear now. It is not difficult to score 5 marks. 1 mark is here for your this formula. 1 mark is here for your efficiency formula. Again, 1 mark is to use all these calculations right here, and 1 more mark is to convert this all into percentages. And I believe that now 1, 2, 3, 4 marks. So I believe that it is going to give you 1 more mark here, 2 marks for this formula. Okay, are placing values here, or simply you can say either you will have 1 mark, 2 marks here, or 2 marks here, because at the top you have to put different values and at the bottom you have to put different values. Is this clear? Any confusion in this question?
No, sir.
No, sir.
Okay, now the same type of question is asked in the different variant of another paper. It is related to a wind turbine. That 3.1 shows the model of the wind turbine uses to demonstrate the wind energy to generate the electricity. The wind is blowing towards the model as shown in the figure. Okay, so there is a circular area swept out by the turbine blades, and voltage and ampere are written here. So it means the generator is fixed at the bottom of this turbine. The mass of the air passing through the circular area swept out by the turbine blades each second is 0.7.5 kg. This is very important question. I mean, trending question hai ye, because in this the mass flow rate is given to you. Okay, and it is 7.5 kg per second. The kinetic energy of the air passes through the circular area is 240 joules. What is the kinetic energy? That is 240 joules. Okay, and calculate the speed of the air, right? So what I have to do, I have to use that formula, that kinetic energy is equals to 1/2 mv square, 1/2 mv square, which is equals to 240 equals to 1 by 2 mass per unit time. What is mass per unit? I mean mass per second. That is, okay, again there is very interesting equation that in each second, it means this is actually the energy is equals to power into time. Okay, and if you just consider time as 1 second, so energy is same as power, so you will not have any problem with mass. It is 240 joules in 1 second, and this is 7.5 kg in 1 second. So here we will replace this value with 7.5 kg in 1 second, and then here we are going to solve this v square. So just 1 second will be gone with 1 second, 2 will be multiplied on the other side, so v square will be equal to 2 times 240 divided by 7.5. And when you are going to calculate v, whatever its answer will be, you will take square root of that. Okay, just take square root and let me know the value.
8 meter per second.
Okay, its speed is 8 meter per second. So you will write
Sir,
your
what were
answer
you?
into two significant figures. So you will write 8.0 meter per second. Is it clear to you?
Sir, what is the role of 0?
It is just to make you clear that the number of significant figures followed here, they are same. I mean, in one number there are three, in one number there are two. So we round the answer to the least number of significant figures in the data.
Okay. Also, sir, what were you explaining about the per second thingy? I didn't understand that very well.
Yes, sir. Me
Ab-
too.
about what?
A
Sorry.
per second that it is
Hmm.
240 per
Okay,
second.
okay, okay, okay. Yes. Actually, what I was explaining here, that you are given mass per second, right? Usually, what do we have? We have mass now, not mass per second. It is
Yes.
that the turbine blades sweeps 7 kg per second. So it is mass per second is called flow rate, or we simply call it mass flow rate. What do we call it? Mass flow rate. That how much mass is swept per second. So when you put that in the formula of kinetic energy, he has given that kinetic energy per second, not kinetic energy simply. If you see the statement, isn't it? It is the turbine blades. Sorry, the kinetic energy of the air that passes through this circular area each second. Time is given there. Okay, so kinetic energy per second is given to you, and then you will write 1 upon 2 mass per mass into velocity square. So energy divided by time is given to you. So you have to divide this with time also. Why? Because if you are dividing kinetic energy with time, it becomes power. Okay, it becomes power. And here, if you are going to divide kinetic energy's formula with time, again it is power. So it is kinetic energy is 240 and time is 1 second. And then 1 by 2, mass is 7.5 kg and time is 1 second and velocity is to be calculated. Now you got it that what I was explaining for seconds this way.
Yes, sir. Sir, मगर आपको कैसे पता चला कि काइनेटिक एनर्जी वाला लगाएंगे फॉर्मूला?
क्योंकि मेरे पास उसने दिया हुआ है ना काइनेटिक एनर्जी ऑफ द एयर इज 240 joules.
Mm-hmm.
इसलिए yes, do you have any other question? Clear हुआ या दोबारा बताओ?
नहीं सर, क्लियर हो गया.
I got it, sir.
Okay, so now the next part of that is 1 or 2 marks questions, simple one. The kinetic energy of the air drives the generator. State the input power of the air passing through the turbine. So this is now a technical stuff. That input power was basically the wind's kinetic energy. So power is equals to energy divided by time. Okay. Here you are supposed to state. State means the value is given to you. You just have to extract it out and write it. So energy is 240 joules and time is 1 second. What is input? Again, it is 240, but now unit will be used, changed. So it is 240 watt. Is it clear to you?
Okay, got it, sir. But like, sir, when it says to state, we don't need to do the calculation, right?
No,
Like,
no, no, no need. Whenever state word is asked to you, state means the values are already given to you. You have to just figure them out from the given data and write it in the answer.
okay, got it.
You got it? Then the output current of the generator is 2 ampere. Output current of the generator is 2 ampere. The output potential difference of the generator is 11 volts. Calculate the output power of the generator. This is that question what I have told you, that power output are simply power is equals to V times I, and V is what? V is your 2 ampere. Sorry, V is your 11 volts. V is 11 volts. And what about the current? Current is your 2 ampere. So you have 22 watt output. How much? 22 watt as an output. Is it clear to you?
Yes, sir.
So calculate the efficiency of the wind turbine. Again for 2 marks. So what is your efficiency? Recording. Efficiency is equals to useful output divided by total input. Total input times 100, because percentage is given to you. That's why I put 100 here. What is the output? Output was your 9 watt. Sorry, 22 watt. Output is how much?
22 watts. Yeah.
22 watts. And what was the input? It was 240 watts times 100. Yes. ये solve करिए please.
Mm, 0.166,
बोलो
so 9.17.
दोबारा बोले.
9.17 after rounding off.
Yes, 9.17. You will round it up to two significant figures. Here you see 2.0 and 11. There are two significant figures. So you cannot write three significant figures. So your answer will be 9.2%. Okay?
Sir, but wasn't the 240 and 3 significant figures?
Yes, but the least number of significant figures are two in the data. So answer will
Okay.
not follow the highest number of significant figures. Answer will follow the least number of significant figures. Okay?
Okay. Got it.
Okay. Then the density of the air is 1.3 kg per meter per second. Recording, streaming. Okay. So calculate the volume of the air passing through the circular area swept out by the turbine. Again, 2 marks. So for this question, you must see that this is the turbine, and that turbine is basically sweeping out the air inside. For example, air is just coming into this hall, entirely this area. So this is what this is the this is actually just taking the air in. So that the air taken into is equals to mass, sorry, volume is equals to uh, we will use the density formula. Density is equals to mass by volume, and then volume will be equals to mass divided by density. Okay, is it clear to you? So
Yes, sir.
we will move to this part, that what was the mass getting entered in 1 second. That was 7.5 grams, 7.5 kg. So you will use that information here. देखो, part 1 की information you are using right here. So 7.5 kg, and what is the density? 1.3 kg per cubic meter. So just calculate this please for me.
Five point eight.
5.8.
8.
Again, two significant figures. So you will write
Yes.
5.8 cubic meter, because he has not given you the unit. So if unit is not given to you, it's your choice to write down it.
Sir, but
Okay?
it is extracted from the question, right? The meter cube thingy.
Yes, exactly. It will be extracted from the question.
Oh, okay. Got it.
Okay. Zainab, Khadija, and Mariam, all clear?
Yes, sir. Yes, sir.
Yes, sir.
Okay. So I believe that for theory parts, it will help you out. Let's talk about the solar question. Then I will move to the MCQs part. Figure this is question number 119. That is May June 19 question, paper 42. And question number 3. At that figure shows a solar cell used to generate the electrical energy. State the main form of energy transfer from the sun to the solar cell to generation of the electrical energy. Yes. So what type of energy is being transferred from in which form? So that is your nuclear energy in the sun. Nuclear energy is converted into electrical energy. That's it.
So nuclear energy.
Yes, nuclear energy of the sun, because in sun, nuclear fusion takes place, right? The hydrogen
Oh
and
yeah,
helium, all those
yeah.
are getting fused together, and due to that, what happens when they will fuse together? We will have some radiations, and those radiations are actually the electromagnetic radiations. So when they will reach to the solar, they will convert that. Solar will convert its uh, solar energy into electrical energy. So you can write one more step here, that nuclear energy is converted into solar energy, and then solar energy is converted back to electrical energy. Okay.
Okay, sir.
Sir, your mic isn't on.
Yeah, if you're saying something.
Okay, sorry. I did not notice that I'm at mute. So they do not cause pollution. And what is disadvantage? Disadvantage is that they cause
Money?
global warming.
Oh,
Yes, global warming, right? You know
So what
why?
if we write that they're a dilute source of energy?
Dilute source of energy, sorry.
Like they produce less energy as compared to the fossil fuels, so the energy produced by them is like dilute.
Yeah, that is once in terms of advantage, one more advantage came to my mind, that is a renewable source of energy. And secondly, inefficient. They are not more efficient. And again, there is a disadvantage, that you cannot use them in cloudy weather. They are not yani, useful in all circumstances. Zainab, am I right?
yes, sir.
Not useful in cloudy weather. So that is a limitation of those. State and explain whether this source of electrical energy is renewable. So yes, I told you that is renewable, because solar energy is that much in amount that we consider that it is not being utilized by the solar panel or solar cell. Each group of solar cells, yeah, this is very interesting and important and trending question. Again, okay, this one, that each group of solar cell is arranged in a rectangular setup of your 1.2 meters and 2.8 meters, right? This is basically the dimension of your solar panel, right? A group of cells is arranged in a rectangular way to 1.2 into 1.8-meter solar panel. The solar cells are situated in a region where 260 watt of the solar energy is received per square meter. Again, very interesting thing of the cell. The electrical output of each group of solar cell is 2.5 ampere with a potential difference of 86 volt. Calculate the efficiency of the solar cell. So for this question, I mean, maybe I will have some less space, but I will try to manage that all. first of all, I will just eliminate this shades and I will shade this area. Okay, for example, if you have this, if you have this solar plate, and in that solar plate you have its dimension as 1.2 meters and 1 point, sorry, 2.8 meter in this way. Okay, and that is directly exposed to sunlight, right? And in this zone it is taking 260 watt per square meter, per square meter. So first of all, I will calculate its entire area of this solar plate what I have, that is 1.2 into 2.8. Yes, just let me know what is the total area.
3.36.
Yes, 3.36 square meter. No need to round it off because it is not the final answer. Okay, now power for 1 square meter is 260 watt. I mean, this is power input, right? And power input for 3.36 square meter will be equal to 260 times 3.36. So what did you get?
873.6.
873.6 watt. It is actually the input power of your solar plate. Are you getting?
Yes, sir.
This is input power. Okay, power input. Now, what is output power of this group? Output of this group, what you have, its output is V into I, because it is converting electrical energy. And when you are going to convert it 2.5 times 86 kariye zara, what will you get?
215.
215 watt. That is your output power. What is that? It is your output power. So is this leading towards energy efficiency? This is your output power. So when you talk about efficiency, efficiency is basically, I'm not going to write that formula directly because I have less space, but you can write output power divided by input power. So 215 divided by 873.6 times 100. Yes, what answer you are getting? Yes.
Just a second. 24.6.
Yes, 24.6, which is equal to 25% efficiency. So you, as I told you, that your solar has small efficiency, 25% efficiency. Okay, is it clear to all of you?
Yes,
Yes,
sir.
sir.
This was a horrible question that I have selected for your uh, solutions. I believe
Sir,
that
why
now
are
you
the
will be.
efficiency questions so horrible?
Yeah,
Yeah,
real.
actually, efficiency is a horrible term. Actually, everyone is basically trapped for efficiency. So all the questions which are having efficiency areas, you have to find their input power, output power, and then you have to use for efficiency. Okay, is it clear to you?
Yes,
Okay,
sir.
sir.
Okay, now I'm going to. Yes, this is again a horrible question. 123. It is in May June 2018 paper. Figure shows an aircraft on the deck of the aircraft carrier. Okay, and the aircraft accelerates from rest along the deck. The takeoff at takeoff, the aircraft has a speed of 75 meter per second. The mass of the aircraft is 9,500 kg. It is its mass. It is its velocity. Calculate the kinetic energy of the aircraft at the time of takeoff. So this is easy part, and you are scoring very good marks. That is,
Two,
kinetic energy is equals to 1
one.
by 2 m v squared. Okay, are you agreed? What is that? Mass is 9500, and what is the speed at the time of takeoff? 75
Sir,
meter per second. Yes. So what will I get?
sir, to how many significant figures should it be rounded off?
Uh, 95 has 2, 75 has 2. So your answer should be rounded off to two significant figures. Just tell me the answer, then I will round it off for you.
It is 267, 187, 50.
Good. So I have to shift. Actually, here is the decimal. So I have to shift this decimal right here. Okay. So then I will round it off. So when I will shift this decimal here, I am getting 2.67 into 10 raised power 1, 2, 3, 4, 5, 6, 7. Right? 7 joules. So again, there are three significant figures, and when I will round it up to two significant figures, it becomes 2.7 into 10 raised power 7 joules. Either you write this answer, it's okay, you will you will be awarded with marks, or you write 27 into 10 raised power 6 joule, or you write 27 megajoule. All are correct. Yes, sir. Is it clear to all?
Yes,
Sir,
sir.
but doesn't the second one, it doesn't like kind of really make sense because shouldn't the index, like the notation kind of be
No,
before
no, no,
like
no.
two
ये वाला
thingy?
ना, yes, second one. This one is not that much suitable, but examiner accepts it because there are two significant figures, and you are having power of 10 in terms of your prefix.
Uh, okay.
Okay, so the last answer is most suitable with some numbers and prefix form. Okay, clear?
Yes, sir.
Okay, then but last question है ये. Correct, the aircraft carrier, a catapult provides an accelerating force on the aircraft. The catapult provides the constant force at a distance of 150 meter along the deck. Right? Aircraft carrier travels 150 meters distance on the deck. Okay. So it starts from here. So let's say its initial speed is 0. Just 2 minutes. I'm just finding it. And its final speed is 75 meter per second. And now the force is, when it is taking off from here, it has covered 150 meter from this point to this point. So all of the kinetic energy is basically provided by what? That catapult, na? Which is basically releasing it from here. Okay, so you will say that kinetic energy is equals to work done by that catapult. So that is equals to kinetic energy you have calculated 2.67. It is enough into 10 raised power 7 is equals to F into D, right? And you are supposed to calculate force. So force will be equals to your answer of kinetic energy. It is better to use the answer of the calculator. Do not delete answers after calculations because they are used in further steps. So divided by 150. So how much force that catapult is providing?
Mm,
Yes, shabash, shabash, come on.
1.7 into 10 to the power 5.
Yes, 1.7 into 10 raised power 5 Newton. You will use that answer. Okay? Is
Sir,
this
but
clear to all of
how
you?
do we know that we have to use the work down thingy here?
Because there is no other option for you. You have to find force and distance is given to you. That's it. That's why I
Okay.
solve these questions for you, that you must get idea that when we are having these type of questions in front of us, then what techniques can be used.
Oh,
Okay.
okay. Yeah.
Yes. So that's all till today's class. We will be inshallah discussing further in next class. I believe that now you people will be able to handle the questions.
Yes, sir.
Sir, is there any
Inshallah.
homework or stuff?
Yeah, that is the homework. What I have sent you, I have already sent this worksheet to you people. So you people will try all these questions